Okay. Welcome everyone to the GIA Knowledge Sessions, a series of talks and seminars about gemology fueled by our decades of research. At GIA, we consider ourselves so fortunate to be able to study and learn from gems, and it's our mission to share our discoveries and learnings about the world. I'm so excited to kick things off today. Now, I'm Robert Weldon. I'm the director of the GIA Library, and I'm joined by Dr. Palke and by Joanna Joy Seetoo. Dr. Palke is the Senior Manager of Research at GIA based out of the Carlsbad Lab. He works mostly with color gemstones, and his primary focus is on geographic origin determination and treatment detection. Joanna Joy Seetoo is subject specialist for our jewelry manufacturing arts program here at GIA. She is an award-winning jewelry designer, goldsmith, and certified crystal healer. Her designs have been seen on feature films or in feature films, television, and in print. Okay, so just before we get started, a little bit of housekeeping. Everyone attending is automatically muted. So if you have a question, please submit it using the Q&A feature you'll see at the bottom of your screen here. Feel free to ask questions as we go along. There will be a Q&A session at the end where Dr. Palke and Ms. Seetoo will have the opportunity to answer some of your questions. We'll also send a recording of the session to you later today, and that message will have a survey in it, and we'd love to hear your feedback. And with that, I'm going to pass you over to Dr. Palke and Joanna Joy Seetoo.
Thank you, Robert. So Joanna and I are really excited to talk to you guys today about red gemstones. I'm going to cover a little bit of the gemology of the red gemstones, and Joanna is going to focus more on the history and the lore and the more romantic aspects of the red gemstones. And so, as you may have guessed, we chose to talk about red gemstones today because Valentine's Day is coming up. And so red is sort of the color associated with love and romance and passion. So this just kind of ties in with the coming of Valentine's Day soon. So before we start with the gemology and the history and lore, though, I want to just give a little bit of a basics about some color science and kind of why we're talking about red. So I would, first of all, make the case that humans are sort of different from a lot of the other mammals in the world in that we have trichromacy. So if you think back to some basic color science you may have learned in high school or in grade school, we have in our eyes these cells called cone cells. And there's 3 different types of cone cells. These are the cells in our eyes which are responsible for absorbing color and transmitting signals of color and light to our brains. And we have 3 different types of cone cells that are sensitive to different wavelengths of light. So we call these the blue, green, and red cone cells. And that's shown here, where the optimal sensitivity of each of these cone cells is shown in the range of visible light. And the one thing that makes humans different from a lot of other mammals, we are very much dominated by our sense of color, of light, whereas a lot of other mammals are more dominated by the sense of smell. And I think you can separate those two between trichromacy and dichromacy. So the animals that are more dominated by smell, like dogs, are dichromic, which means that they only have 2 types of cone cells. So they can't really distinguish between all these colors that humans can. And especially one of the main reasons that we have evolved trichromacy is to differentiate between green and red light. And I'll actually show that here. This photo here shows this really well. This is a bullfighter with a red cape. And we often see this red cape with the bullfighters. And so it sort of makes sense on face value if you're trying to aggravate the bull to use a red cape, because in the West, especially, we often think of red as being associated with aggression, or it's kind of the color of war. And so you might think this should make the bull angry, but in fact, the bull is dichromic. So a bull only has 2 types of cone cells in its eyes. It probably can't really distinguish that red from green. And it probably sees red and green in shades of sort of gray. So that red really means nothing to the bull, but it's probably something about, it means something probably to the bullfighter, because the bullfighter sees this red as the color of war and aggression and passion. And I would make the case, I think Joanna will talk a little bit more about this later, about how colors affect our emotions and why red is so important for us. But I would make the case that out of all the colors we can see, red really is one of the most important. And so what this is showing here, there was a study done back in sort of the 1960s by these two scientists, Berlin and Kay. And they looked at all these languages around the world, and they looked at specifically the color vocabulary of different languages around the world. And they broke this down. They said there's essentially 11 sort of fundamental color terms that you can have in languages, in any language in the world. So we have, black, white, red, green, yellow, blue, brown, purple, pink, orange, and gray. Those were the fundamental color words that you could have in a language. And they looked further at, not every language in the world has all 11 of these color terms. And so they wanted to see if there was some sort of structure to this in terms of when colors are added to a language and why. And what they found was that languages that have more simple color vocabulary that might have only terms of the fundamental colors, black and white. So if you only have 2 color vocabulary terms out of these 11, you're only going to have black or white. And there's obviously exceptions to these rules, but they found that overwhelmingly these trends very well explained what was going on with color vocabulary and complexity of languages in color. But they found that, interestingly and importantly for this talk, if you were to add one additional color term to your language, the next color term generally and most commonly was going to be red. You wouldn't add purple or pink or orange after making words for white and black, or light and dark. You would then add red. After that, it would be green and yellow and blue and brown. But basically what this shows is that out of all those that we thought it was important to describe and it was important to be able to communicate with our fellow humans, red is one of the most fundamental of those colors. And I think there's a lot of reasons for this. This red basically just strikes us more heavily than I think a lot of other colors. It has this emotional effect on us that is not as strong as some of the other colors. Now, that's kind of where I'll stop with that. I think Joanna might touch on that a little later, but I want to give you an idea of the structure of the rest of the talk. We're next going to go over several red and in some cases pink gemstones. And I'm going to talk a little bit about the gemology and what's causing the color in some of these stones. And Joanna will go into some of the history and lore behind the stones. So without further ado, I'm going to start with the first stone we'll talk about. And of course, if we're talking about red gemstones, the first stone has to be ruby. Ruby is the red variety of the mineral corundum, which is an aluminum oxide mineral. It's uniaxial. The refractive index, if you've ever done a GIA course on gem identification, you can identify ruby or a sapphire easily with a refractive index 1.762 to 1.77. Fluorescence can be a key with identifying a ruby. It's often got strong to weak to strong red fluorescence under long wave and short wave. This photo shows a really nice star ruby, which is a really interesting phenomenal variety of ruby. Those stars are caused by the scattering and the orientation of these silk particles in the stone. This is a photomicrograph of a Burmese ruby. I didn't write the name of the photographer, but this was taken by a colleague, Gib Charwan, in our Bangkok office. That's a fantastic photo. But these oriented needles are the cause of that asterism, which you might see in some star rubies. Now, why is a ruby red? I started off the title of the slides in the first part was ruby is red. So the reason ruby is red is that we have here the corundum lattice. I'm showing that on the right. So this is the atomic structure of corundum, of ruby. The blue spheres are aluminum atoms and the red spheres are oxygen atoms. I mentioned ruby is an aluminum oxide mineral. So if you have just aluminum and oxygen in your crystal lattice, you're not going to have any color caused. If we replace some of those aluminum atoms with chromium atoms, though, all of a sudden what happens is you start absorbing some of the light that comes into your stone. And that looks like this. So this spectrum I'm showing here, this wavy line, is a spectrum of a chromium absorption in the mineral, in the gemstone ruby. So what you're seeing is that the wavelengths of light on the horizontal axis from 380 to 780 nanometers. And so that corresponds roughly from sort of violet to blue light all the way into the red at longer wavelengths. And what we see is that when chromium enters the crystal structure of ruby, of corundum, you absorb a lot of this light in the blue and in the green, and you allow all of this red light to be transmitted through the stone. So when this line is higher, that means more of that light is absorbed by the mineral. And when the line is low, that means more of that light gets to pass through the stone and come back to our eyes. And so this is the fundamental reason, of course, why when you take white light going into the stone, it absorbs all of that green and blue light and allows that red light to pass back up to our eyes. And if you ever look through a spectroscope, you might realize the similarities between this absorption spectrum and the patterns you would see in a spectroscope in a gem identification class, for instance, or if you're out in the field trying to identify a ruby with basic gemological tools, you might see the same pattern in a spectroscope. There's one more important feature I want to talk about with rubies, and that is that a lot of the top quality, the really high quality stones, especially from places like Burma, where you have marble-hosted rubies, they often have this sort of glow to them. If the color is really bright, if the stone has low iron, the stone can almost seem to glow from within. And there's actually a reason for that, which is that it is sort of actually glowing. And we call these stones often pigeon blood ruby, where there's very high fluorescence and where the fluorescence is contributing to the color. And so I'll show you what that looks like on the next slide. This is another spectrum, only this is not an absorption spectrum. This is a fluorescence spectrum. So this is sort of the opposite of the absorption spectrum, where what I'm showing here is the wavelengths of light on the bottom from 400 to about 780 nanometers. And also shown is this wavy line. You see there's this big spike around 695 nanometers. This is not light being absorbed by the stone, but this is actually light being emitted by the stone. So the stone is actually taking in light of other wavelengths, of shorter wavelengths, and re-emitting it as intense red light. And you might, if you've ever seen a fluorescent spectrum of a ruby, you might be more familiar with this pattern. I'm showing a different scale on the horizontal axis from 675 to 725 nanometers. There's actually two sharp peaks at about 692 and 694 nanometers. And this intense emission of light is what caused that glow in some very top quality fine pigeon blood rubies. Just one more slide on this before I bore you guys with the technical details. But this is actually an excitation spectrum. So what I'm showing here is sort of the efficiency by which certain wavelengths of light, when they strike the stone, the efficiency by which those wavelengths of light can excite that chromium emission. And so what I'm showing here, there's this big broad absorption band, or broad emission excitation band at around 400 nanometers. So what this shows is that you don't really need ultraviolet light in order to excite that fluorescence in the ruby. Really, there's a lot of wavelengths of visible light that excite that fluorescence in the ruby. So even if you take your nice pigeon blood ruby out into the daylight, there's going to be plenty of blue light that will cause that red fluorescence in the ruby, giving that nice brilliant glow in the fine, really low iron pigeon blood rubies. So that's what I have for the technical details of the rubies. I'm going to turn it over to Joanna now to talk more about the history and lore and the more emotional aspects of ruby.
Well, thank you, Aaron. I always love hearing how science supports what we intuitively feel. So as Dr. Palke said, red is a color that evokes passion. It's a really, really emotional color, wouldn't you say? And I would think that when you're looking at color in general, in life, in the world, think about how it affects your mood. We know from poetry, from song, that red is a very potent color. Robert Burns wrote a beautiful poem that says, "Oh, my love is like a red, red rose." We think of red when we think of romance, when we think of desire. And things like, oh, there was a song called The Lady in Red. I don't think any one color has actually been so used to describe a wealth of passion. And in certain cultures, red is really the color of luck and prosperity. And I think we would say that red is really the color of life and vitality. We talk about lips being red. And so I would say that in general, if you were to think about even the feeling of desire, people would think of red. Aaron brought up before about the bullfighter, and I'm sure we've all heard the expression, I was so angry I saw red. So if you envelop that into your own living and how you deal with your gems, whether you're selling, collecting, whether you just love them, think about how those colors make you feel. And you'll know why certain gemstones have been assigned certain properties. So we look at something like ruby here. And if you notice the bullet points that I've put down, things like power, wealth drawing, passion, love, fidelity. Before diamonds were a thing for engagement rings and wedding rings, colored stones were actually the more popular choice. So people even more recently got engaged with color. Both of the Simpson sisters got engaged with color. I believe Sarah Ferguson and Princess Andrew were engaged with color. And even Victoria Beckham, I believe, was engaged with color. We can go to the next slide, Aaron. So when we see these different colors, and Aaron could really explain much better all of the different, I mean, he was talking about the fluorescence. And so we see these different tones in the rubies. I want you to just take a look at these wonderful images that we got from the GIA library, which thank you very much, Robert, and everybody there. How do they make you feel? Are they exciting? I mean, they excited me. When I got to take a look at these, I was super thrilled. Can we go to the next one? So if you noticed all of these different tones and how they would make you feel all of the different aspects of life force, courage, right? Because we have all of these different things in the color red that we have assigned. Move on. And here we have a beautiful pair of earrings. So now we come into how do we use these colors in our wearing? And if you think about it, everything that we put on, jewelry in itself, in our world of gems and jewelry, these are talismans and amulets that we've used culturally, historically, since the beginning of time. And you have to wonder, why is that? Why has this lineage traveled with us throughout every culture? Well, think about it. And perhaps the things that we put into these precious items are as valuable as the items themselves. It's the belief in what they'll do for us. And I think that's good. I think I'm going to hand you back over to Aaron.
Thanks, Joanna. Really fascinating. So the next stone we'll talk about then. Oh, we forgot
we
one.
Got the frog.
The frog.
And, you know, I mean, and this is actually one of my favorites, this carving, because we all know the fairy tale, right? Of the princess and the frog.
A really good way to end with Ruby there. So the next one up is the next stone we'll talk about is SPINEL. And SPINEL, I think, follows naturally from Ruby because in the times of antiquity, before there was sort of this marriage between the sciences of mineralogy and gemology, a lot of these mineralogical techniques that we draw upon in gemology hadn't really been used so much to kind of identify stones in a very systematic way. And so it used to be, in a lot of cases, stones were identified based on their color. And so we often talk about like balass ruby. SPINELs were actually sometimes misidentified or actually just called ruby in these old times because they didn't have the proper tools to really separate them or the knowledge to know that there was a difference between these two mineralogical species. And so the most famous example you'll see is the famous rubies, the rubies, I should say, in the crown jewels of the English crown jewels, and specifically this big fist-sized red stone in the crown here is what's called a ruby, but it's actually a spinel. In modern times, spinel has become to be more appreciated on its own right for its vivid saturated colors and its wide range of hues. And so it's actually coming to, in some ways, compete with the ruby for those very high-end, the very high-end market for very fine red spinels. So the science of and the gemology of spinel. Spinel is the mineral spinel. There's actually a group of minerals in the spinel group, and we're talking about the strict mineral spinel, which is magnesium aluminum oxide. It's singly refractive, so it's a cubic mineral in a crystallographic sense. Refractive index of 1.718 identifies spinel and separates it from a lot of the synthetic or lab-grown material. You might see some fluorescence, as you saw with the rubies, and we'll get to that in a minute. One thing with spinels is that you might see some fracture filling in terms of treatment, but generally treatment is uncommon with spinel. And so that's one of the actually selling points of spinel, is that if you're buying a really fine spinel, it hasn't been subjected to heat treatment, and it's most likely that color is the color that it was given when it came out of the ground. Now, with spinel, what causes the color of spinel? And it's the same thing essentially as we saw with ruby. So we take some of those atoms in the spinel structure and replace them with chromium ions, chromium 3+ ions, and that starts to selectively absorb some of the light that passes through the spinel. So it's a pure magnesium aluminum spinel would not absorb light really at all. You add some chromium in there and you start to absorb light in the green, the blue, and the violet regions. And that allows all of that red light to pass back through. With spinels, you often have these very bright red spinels. You can have slightly darker stones when you start to add in a little bit of iron into the structure as well. You start to darken the tone of the spinel, and it doesn't really change the hue so much, but it starts to really kind of darken the tone. But you also do have some really highly fluorescent spinels. And so we sometimes hear about these Jedi spinels, or these spinels from Mancine and Mogok, which have these bright, vivid, almost glowing colors to them. And the same phenomenon is responsible for that as well in spinel. So if you have a bunch of chromium and low iron in your spinel, you can get very intense fluorescence. And one interesting thing about the fluorescence in spinel, I'm showing a spectrum down here of the fluorescence for natural, heated, and synthetic spinels. And you can actually use the pattern of the fluorescence in your spinel to tell you if the stone's been treated at all, or even to separate lab-grown spinels from natural spinels as well. So those are some of the interesting things about spinel from a gemological perspective. Now I'm going to hand it back over to Joanna to talk about some of the lore and the mystique about spinels.
You know, spinel is actually one of my very favorite stones in all of the different color variations, but the reds have always really kind of spoken to me. And I think it is because they're so incredibly vivid. When you think about those, and you'll see from, as we go through the slides, a lot of the metaphysical aspects that are assigned to these red stones definitely will be repeated. And a lot of that does have to do with the color itself. So if you are, let's say, let's move to the next slide. So let's say you are somebody who wants to either use spinel for making, or you are looking to sell to your customer. I think that there are certain things that you might want to just kind of layer into the story of what those stones mean, and why you might want to use them for an important piece of jewelry. I mean, in our field, there are very few times that anybody who is working can say that they are involved in an occupation that is purely surrounded with love. Who gets to say that? Certainly not your lawyer or your doctor or your accountant. We don't give pieces of jewelry or precious gems to somebody that we don't love, or even if we collect it ourselves, it's because there's a love there. And I think that that holds a lot of value right in there. Mic drop on that one. Let's move to the next slide. I mean, look at this. Look at the glow in that stone. Who wouldn't want to harness the vitality of that in their own life? You talk about a power stone, you need to go into an important meeting, an important event. This is the kind of thing that you would want to be wearing. This is the kind of piece that would make you feel strong, would give you those aspects. Thank you, Aaron. This spinel is so different from the one before. And it doesn't have that glow, but it certainly has that rich, rich red, right? We might not be seeing it because of the image, but if there was anything that I would say would give somebody definitely a sense of that strong encouragement and strength and power, this would be a great color for you to bring that into your life. Yes, spinel is an awesome stone.
All right, sorry, I jumped the gun.
No.
So the next stone we'll move on to then is pink and red diamonds. Now, I'm not really much of a diamond person. I'm more interested in colored stones, but we do think this one is important, especially in conjunction with Valentine's Day, to talk about diamonds. So the gemological and sort of the physical and chemical aspects of pink diamonds, pink to red diamonds. The pink is caused by absorption of blue-green light by a very broad absorption band at around 550 nanometers. That's shown here on the bottom, allowing transmission of all the red light back to our eyes. One of the interesting things you'll see with pink to red diamonds, when you look at them in the microscope, you turn them to the right angle and you actually see this, the color is usually not very uniformly distributed. It's often concentrated in these layers, these planes throughout the diamond. And what's actually going on with this is we believe the color center is responsible for the pink color and pink to red color in diamonds is caused by plastic deformation. So somewhere deep within the earth when these diamonds formed, they were being squished and contorted by the forces of the earth. And the strain that was accommodated by the diamond was accommodated in these planes. It sort of concentrated the strain in these planes, and at the same time when the diamond was being deformed, it caused these defects in the diamond that are responsible for that red coloration. And so that's kind of the story with pink diamonds from the scientific perspective. I'll hand it back over to Joanna.
So one of the things I think we most see synonymously now with love, engagement, weddings, especially are diamonds. So we're because of this topic, we're looking at pink and red, but you know, and most of you probably already know this, but well, actually, when I was looking at this was new to me. So I know that a lot of people felt that the first engagement ring was actually in 1477 with the Archduke Maximilian of Austria, that when he got married or proposed to Mary of Burgundy. But actually, Costanzo Sforza in 1475 preceded him with the Sforza ring, which was actually considered the first engagement ring, diamond engagement ring, when he was to wed Camilla d'Aragona in Italy. So there's a little factoid for you. We all know that a diamond is forever. Became De Beers' signature. And that in itself actually changed how we view diamonds as the ultimate symbol of love and commitment. And in fact, in 1947, when Francis Garrity wrote that for N.W. Ayer, eventually that slogan became known in 1999. Advertising Age actually lauded it as the slogan of the century. And that's how important that became. Diamonds itself became so important and ingrained in our culture for this lasting commitment. And you know what, metaphysically, the properties of a diamond, there are reasons for that. In essence, if you were to try to bring in love or romance, I would maybe take a look at different stones from a crystal perspective, crystal healing perspective, but certainly the aspects of diamond for invincibility and invulnerability, like who doesn't want that in their marriage, right? Constancy, abundance, longevity, all of those things are really, really important. And outside of that, well, who couldn't use a little more charisma?
Boy, invulnerability is a good thing going into a romantic relationship.
Well, there you go.
Or the feeling of it anyway.
So says Dr. Palke. Believe it.
So the next stone we're going to talk about is garnet. Again, one of the more common stones we think about with gemstones that are red. And actually, there's a little more subtlety to this in a scientific perspective. Garnet's this big group, and even it's a super group, according to the mineralogists. I went through this actually recently with a colleague from Australia, Andy Christie, who's a crystallographer, and he helped me figure out how many different types of garnets there are. And I think there's actually like 17 garnets in the group and something like 35 garnets in the super group. Now, we're actually only going to talk about really 3 main stones, garnet species for the red stones. And that is pyrope, almandine, and spessartine. You don't typically find the red gemstone varieties outside of this sort of group of what we call pyrospike garnets. Shown in the photo is a whole wide range of different colors of garnets, but you'll see it's sort of divided between reddish stones on the left and the green stones on the right. The stones on the right are actually grossular and androdite type garnets, whereas the stones on the left are dominantly more of the pyrope, almandine, spessartine garnets. I think there might be a grossular in there somewhere. Occasionally grossular will be slightly reddish, but for the most part, we're talking about pyrope, almandine, and spessartine. Now, garnet is this group. So the group has this basic formula, X3Al2Si3O12. I'm not going to dwell on that too much, but just to kind of point out that there's this wide variability in garnet species because there's all these different crystallographic sites where we can put different elements in there. You substitute different elements in the structure and you create different mineral species. Garnet is a singly refractive mineral, but because it has such wide variability in its chemistry and it's the species, the refractive indices and specific gravity and a lot of the other properties vary quite widely. Now, one thing that's sort of important with garnets, especially the red garnets, is it's not very common to find treatments in them. So there's not really any heat treatment methods for improving the color. So the color that you get in a red garnet is basically the color that the stone came out of the ground with. There are some sort of novel lab-grown garnets like YAG, but these are sort of not as common in the and they're quite easy to separate from the natural stones as well. Now let's look at the causes of color in garnets, in red garnet specifically. So the spectrum here on the left, you might notice it looks a little different than I showed earlier. The wavelength range is drastically different. So we're going from 400 nanometers to 1400 nanometers. The visible part of the wavelength, the visible part of the spectrum is only on the very left part of the spectrum. I just wanted to show this because there are all these different absorption bands in garnet. The main one that's causing the red color in most cases is iron 2+. And so the iron 2+ creates these sharp absorption bands in the visible range and this very broad absorption band in the infrared, which is not so important for color, but just kind of to point out that there's all this world of spectroscopy and absorption going on in these stones that we don't really get to see in the visible range. And so again, these sharper bands over here absorbing a lot of the green, blue light, allowing all that red light to come through. If you've ever looked in a spectroscope at a garnet, trying to identify it in the field or in your GemID lab, you might see these bands that are characteristic for the garnet spectrum, and you might see how they line up quite well with the absorption bands that we see in the in the spectrum that we collected with our visible spectrometer. There's one more thing to note, which is that oftentimes with red garnets, pyrope-almandine garnets, you get more intense, more pure red color when you add chromium into the structure. So you can get red without the chromium, but if you add chromium, it sort of intensifies that red color. It does a much better job of absorbing a lot of those wavelengths of blue and green light and allowing all that red light to come back through to us. So that's what I have for the garnets in terms of the gemology. Now I'll hand it back over to Joanna to talk about the lore and history.
Thank you, Aaron. Garnet is one of those stones where you start to look at mythology and like you're hitting the gas pedal now. So one of the things about garnet that we probably all have heard is that it was known as one of the stones that are in the breastplate of King Solomon. And there were several different gemstones that have been noted for that. But garnet is always called out. One of the lesser things that you might not know is that it was said to have been the stone that lit Noah's lantern. And that was the stone that was able to keep light on while Noah was in the ark and his family were in the ark. And one of the other aspects that I love about it is that in Greek mythology, garnet is synonymous with the seed of the pomegranate that Persephone ate when she went down to Hades, and thus her marriage to Hades and why she spends half her time down in Hades. So I love garnets in that they are really a stone of more grounding. And let's go through the slides a little bit here. So you can see these different, this is such a beautiful carving from Meg Barry, and our good friend Arasa Weldon shot this. The colors, the richer, deeper berryish tones of garnet, I'm sure can evoke a different kind of feeling as the reds that we saw in rubies and in spinels. Garnet does have a grounding part of this that I would say the other brighter red stones don't have. It is definitely a stone of commitment, whether that is commitment to somebody else or even commitment to yourself and your own beliefs and values. Garnet is one of those stones that helps you release a lot of negative emotion as well. And so in the surrender, you can surrender to what's going on in your life and in your world so that you can transmute and overcome and bring in the things that it is that you really want to have. It is a stone that when I put down physical love, I think we all know what that means. And so it is known also as a stone of passion. So these garnets are quite spectacular. And you could see those fiery aspects of the love and passion that would be surrounding the energy of these stones as well. Oh, this is another beauty. So again, when you wear garnets, you can definitely feel really solid in knowing that you've got that protection and also that you have these different wonderful energetic properties. Yeah, I could see that that would be lighting Noah's lantern, right? Look at that.
Thanks, Joanna. So I'll follow up next with our next stone, which is rose quartz. Again, not so much a red stone, but we are considering red and pink stones together in this because they oftentimes kind of have a similar effect on us, I think. So rose quartz, again, is the mineral quartz, alpha SiO2, so it's a silicon oxide mineral, uniaxial positive. The refractive index is indicative of the stone, 1.54 to 1.55. The one interesting thing about rose quartz, you can see these stones have a little bit of a sort of a hazy appearance to them. And that actually speaks to the cause of color in rose quartz, in most varieties of the pink quartz that we call rose quartz. And the color is not actually intrinsically derived from the quartz itself, but rather the color is derived from these micro and nano-sized inclusions within the quartz. And that's shown on the right. This is a TEM, a transmission electron microscope image of some inclusions in the quartz and a rose quartz. These are actually micro inclusions of a mineral that's related to or is called demordiorite. One thing you'll note is these kind of blade-like appearance of these inclusions and the sort of oriented nature of the inclusions. You can see they're sort of oriented in a very sort of periodic angles relative to each other. And this is important for the quality of asterism. And I think Joanna's got a really beautiful star rose quartz that she'll show us later. And so it's these micro inclusions giving the color, but also in some cases causing some asterism in the rose quartz. And so the absorption spectrum is shown here. What is actually going on in this stone is that the demordiorite inclusions are absorbing light around 500 nanometers in this range of blue to green. And this is being absorbed by this intervalence charge transfer reaction between iron and titanium in the demordiorite. So if you know, this is similar to the reaction we see in like blue sapphire, for instance, where you have light being absorbed by electrons hopping between iron and titanium, and the light is being absorbed in order to make that happen. So again, you have this demordiorite inclusions absorbing that blue to green light, letting all that red light through, bringing that color to our eyes. So I'm going to hand that over to Joanna then to talk about the lore and the history.
So thank you, Aaron. I love knowing about why certain things happen within the stone to make it look a certain way. Rose quartz has always been one of my favorite stones, even before I got into this field. And once I started to know about the properties of the stone, I knew why. It is, as I say, as you can see, the ultimate stone of love. It attracts love, it attracts romance. It's really great for unconditional love. It's great for self-love. There's a gentle, loving, soft quality that is absolutely conveyed in the soft kind of glowiness of the stone itself. So I would always recommend wearing a piece of rose quartz or having rose quartz in your home. For any of you who might be feng shui people as well, you know, keep it in your bedroom. You know, like you don't want to have arguments there, and you want to definitely keep the energy really, really sweet. And it's a great stone for that. Let's take a look at some of the other slides. Here's the star that Aaron spoke of before. Phenomenal stone. Another great shot from Russell Weldon. Thank you. And you can see, like, this stone feels like really potent, right? And it's got a lot of power in it, even though it is a soft and tender stone. Let's go to the next. This is one of my favorites, actually. So a lot of people are not sure if they could really wear something like a rose quartz frequently, but you can see from this fabulous carving that Glenn Lara did that it holds well for a lot of things. I actually wear rose quartz a lot, even in rings, and I've never had any issues, but certainly you can wear it close to your heart and wear it in a necklace, and I think it would be just a great piece to have with you all the time. And I love this. I know Aaron and I both fought to keep this slide in. This isn't that the most charming thing you've ever seen? I just think it's adorable. And look at the color on that. That's just a phenomenal piece of rose quartz. And it's, Robert shot this, and I'm just so happy it made it into our presentation. So add rose quartz to your life.
I love this stone too. Thanks for letting us keep this one in, Robert. So we'll move on to the next red stone, which is rhodochrosite. So you notice on the right, this photo of this rough piece of rhodochrosite. If you're familiar with a lot of mineralogy, you can maybe see the same type of a shape in the mineral calcite. And there's a reason for that, which is that rhodochrosite and calcite are in the same group of minerals. They're both carbonate minerals, and they take on the same form. The difference between calcite and rhodochrosite, in rhodochrosite, you take that calcium out of the calcite and you put manganese in there. So it's a manganese carbonate. It's a uniaxial mineral. There's very high birefringence, from 1.597 to over the limit in your refractometer. You might have dull fluorescence, but one thing to note with rhodochrosite, it is very soft. It's got a Mohs hardness of about 4, and it's got several cleavage planes in there. So it can be very tough to work with and to polish into a faceted stone. There is some rough out there with very high transparency, which can make very killer stones to look at. But again, it's more of a collector stone, which maybe makes it a little more unique and special to actually get a really nice piece in a faceted material. So just a little bit about the gemology, the science. The cause of color in rhodochrosite is different from any of the other red stones we've seen so far. It's manganese, and specifically it's the manganese 2+ in the structure. So manganese 2+ is actually not a very strong absorber. It doesn't absorb light very strongly, but when you get so much of it in the structure like you get with rhodochrosite, you can start to absorb a lot of that light, producing very striking, rich red colors. It becomes a little more pink when there's sort of translucency to the rhodochrosite, caused by scattering of the light. But when you have transparent materials, very red. And because it's caused by this intrinsic element within the structure, we say that rhodochrosite is idiochromatic, meaning the color comes from the structure itself, from the main components of the structure itself. So that's what I have for rhodochrosite. I'm going to hand it over to Joanna. Well, that's where the color comes from.
Okay, so just really briefly, rhodochrosite is actually another great love stone. So when I was starting to do the research for this presentation, I didn't really know that rhodochrosite was as potent as it is considered by metaphysical people. But one of the really beautiful things about this stone that's kind of unique is that it helps bring suppressed emotions to the surface so that they can be healed. And in life, you know, I think everybody goes through challenges. So that's a really fantastic aspect to this stone. It is a really strong love drawing stone, and there is a certain soothing beauty to the color, whether you've got these fabulous specimens. I think we have a few more where you can see this is really a gemmy rhodochrosite, or even the ones that are a little bit more of what I think they call the bacon fat, like this. So it's an amazing stone for a very kind of love, and it's a great stone if you want to just kind of help balance out your emotions and just amplify a lot of your resonance.
Thanks, Joanna.
Yeah.
So the next one we'll turn to is RUBELLITE. And so RUBELLITE is a varietal name for kind of pink to intense pink to red tourmaline. And again, tourmaline's like garnets, this big super group of minerals. I don't know how many there are in tourmaline. There's a number of different species we can think of. The main one we're going to talk about is elbite. So that's the species where you have sodium, lithium, aluminum, along with the aluminum and silicon and boron in the structure. The general formula for RUBELLITE here, the general chemical formula is shown here with the X, Ys, and Zs and everything. I'm not going to go too much into that, but I put it there to kind of stress that there's this huge diversity in the chemistry of tourmalines, which allows for all these different species and allows for all these different colors, especially. This is a great photo on the right showing kind of the huge diversity in color that you can see in tourmalines. And kind of maybe one of the selling points there is each tourmaline can really be unique because it's got this huge variations in chemistry and the properties of the mineral. So there's a lot of opportunity for diversity and uniqueness among tourmalines in the gem varieties. And so gemologically, tourmaline is uniaxial negative, the refractive index 1.62 to 1.64. Usually not very much fluorescence going on. One thing you would look out for, especially with sort of the pinkish tourmalines, is irradiation. There's heat treatment for peributyramines. Irradiation can be a thing to look out for with pink tourmalines. And let's look at the reason for that. So with pink tourmalines, pink to red tourmalines, and the L-biite species, the color is caused by manganese 3+. So this is the same element causing the color in rhodochrosite, but we've taken one electron away. We've created a different ion. This is manganese 3+. It absorbs light much more strongly than manganese 2+. So you only need trace amounts of this manganese 3+ to create an intense pink to red color. And the thing that can happen with tourmaline is that most of the manganese in most natural tourmalines is going to be manganese 2. But you can irradiate the stone either naturally or artificially to turn that manganese 2+ into manganese 3+. And so what happens is in nature, when you have the stone sitting in the ground before it's been mined, you often have fluids circulating around the stone. Often these fluids contain radioactive elements like uranium, and the radiation from those elements in the fluids can naturally irradiate a tourmaline, giving a nice pink to red color. However, crafty humans have also figured out how to do this artificially as well. And the thing with this pink coloration, it's reversible. So you can heat the stone after you've irradiated it to remove that pink to red color, and then you can irradiate it again and turn it and bring it back. That's also something important for Paraíba tourmaline. I know it's not a red stone, but just to kind of drive this point home, a lot of the stones that are going to become Paraíba tourmaline, the copper-bearing tourmaline that comes out of the ground is often purple when it comes out. And that's because it has some of this manganese 3+ in this structure. So actually people will treat this stone in the opposite way, to heat it to remove some of that manganese 3+ in there, to turn the color into a more saleable, nice, more attractive blue to green color. That's what I have for the rubellites. I'm going to hand it over to Joanna then.
Did you know that tourmaline really was brought to popularity by, I believe it was the Dowager Empress of China many, many moons ago. And we're lucky enough to have some fabulous tourmaline right here in California, some of the finest in the world, as we can see. So one of the best things about tourmaline, whether it's the pink, red varieties or the green varieties, is that it really correlates to the heart chakra. So if you are aware of your different energy centers in your system, that's a really big one, the heart chakra. And I think we could take a look at the next slide. So these rich, saturated colors are certainly really nice for nurturing your own heart and your spirit. I think we have another one, right? Yes. So tourmaline's a great stone to wear. And so you can really harness a stone like this to be able to be worn on a regular basis so that you can feel all of that nurturing and balance, kindness to yourself, kindness to others, that all would emanate from that chakra.
Thanks, Joanna. So for the final stone of the day, we'll talk about kunzite. So not so much a red stone, but a pink stone, and a very beautiful and attractive stone. It's the pink variety of the mineral spodumene, which is a pyroxene mineral with lithium and aluminum as part of its structure. It's a biaxial mineral, refractive index 1.69 to 1.7. Sometimes has some strong to weak yellowish pink fluorescence. One thing to note is that kunzite can be irradiated to produce that color, and importantly, the color can fade. I hesitate to say this a little bit because we're talking about Valentine's Day and love, but the color of kunzite can fade. And that's not to say that it can't be a good stone for Valentine's Day or romance, but maybe it's a reminder that love is fragile, and you have to take care of it, and you have to nurture it in order to make it grow. So maybe that's the selling point. Maybe that's the way to spin this sometimes fading color of kunzite in a more favorable light. They do say if you have nice kunzite jewelry, to keep it in a dark drawer or something when it's not being worn, because the sunlight itself can sometimes fade the color. But again, the color of kunzite than is caused by manganese 3, as we saw for the tourmalines. And again, just like tourmalines, you can sometimes cause that color, that manganese 3, by irradiating the stone. And it can be reversible and it can be removed in some cases. So again, the manganese 3 absorbs a lot of that green light, allowing some of that blue light to come through, but our eyes are more sensitive to the red light that's being transmitted. So even though some of that blue light's still getting through, we're more sensitive to the red that's being transmitted. And so that's kind of the cause of color for kunzite. So I'll hand it over to Joanna from there.
Well, thank you, Aaron. I actually love the idea that kunzite is considered an evening stone, because so much of romance happens kind of in the dark. It doesn't always happen in bright light, right? So, you know, all of those wonderful, soft, romantic feelings, you know, it's an appropriate stone for that. One of the interesting things, though, about this stone is that it does contain lithium. And so if you think about what we use lithium for, there is a calming property for that. And so we see like this nice tie-in for that. It also is a stone that neutralizes negative emotions, which again, you know, is just another layer of the same thing. And it supports and it helps you to be able to discuss and express loving thoughts and feelings. One of the things that you can say about kunzite as just a wrap up is that it fills the heart with love, compassion, and flow. So what better way to wrap up this slideshow than love, compassion, and flow?
Beautiful. Thanks, Joanna. I think that's it for our slides. So we'll hand it back over to Robert, and if there's time for questions, we'd love to answer them.
Okay, let me just get myself in view here. There are quite a bit of questions that did come in. I'd like to ask a few of those. Let's get started with those right away. One of the questions was, what causes the blue, purple, and other colors of SPINEL? This was from Vivian Gornitz.
Yeah, so SPINEL does have this huge diversity in color. It can come in almost any color in the rainbow. The blue is often caused by cobalt. So cobalt, and you can have it in very light tones and in very intense, kind of vivid, bright blue tones, and the really kind of pure cobalt SPINEL. The lavender kind of purplish colors can often come from the element iron, in conjunction with the cobalt sometimes. So that's kind of the blue and the purplish tones and hues in SPINEL.
Okay. And then sort of along the same tones with SPINEL, there's a lot of interest in SPINEL. From Huria Ashraf, the question is, how can we identify the difference between red SPINEL and a ruby through one specific property? Is there one property that really leads the charge to make the differentiation?
So it depends, I guess, on what tools you have at hand. If you had a refractometer, it'd be pretty simple. A spectroscope could help you if you could get a good spectroscope reading. You could look in a dichroscope to look for pleiochroism. You know, there are several tools by themselves that could make that distinction. You know, your best bet is to have a refractometer if you're in a setting where that's possible. A quick look in a microscope would probably identify which one is which if you have some inclusions to look at as well.
And also double and single refraction would probably be one of the things to look for too.
Yeah.
I'm thinking here, let's go to Jack Mazer, who asked the question, what is the history of gemstone lore? Yeah, who and when were the qualities as listed by Ms. Seetoo assigned to these gems? Was there a certain time in the history of humankind where lore just became interesting?
Throughout history, there are certain people who've written down things, and if you go into the ancient texts of Pliny the Elder, look at the Bible, actually lists a lot of gemstones. Those are the oldest texts that I can really think of. And then more modern people, like there's a fabulous woman named Melody who has written kind of a crystal Bible, so to speak. I would definitely look into the work of Henry Mason, because he has broken down gemstones and crystals into their structure and figured out why certain stones would have certain properties.
Okay, that's great. And I think, you know, George Frederick Kunz.
Oh yes, George Kunz, yes.
He translated so much of the ancient history also. So maybe that is another text to be able to look at. Let's see here. So this one's also for you, Joanna. It's this one I think is a little bit less technical. It's really about trends. Are you seeing red spinel used more in high jewelry, perhaps close to or even equaling a ruby? This comes from Irma Wiley with modern buyers. What are the trends for spinel?
Well, you know, I think that once Myanmar opened up, that we were able to actually see spinel coming in is when I saw things opening up a lot. Before, when I started, you would have to really hunt into your gem dealer's old inventory for pieces that were had way before there are any kind of restrictions. But now, yes, I see a lot of spinel entering the marketplace. I'm sure you've seen the popularity of that, just like really trendy gray spinels that are just lovely. There's some of the more like lavendery spinels. I have seen red spinels, but again, you know, one of the things with the reds, we didn't talk about like pricing and things like that, but generally like really, really beautiful red stones tend to be a little bit higher up there on the scale. So if you can acquire them, they are spinel itself, because people are talking about it more, are much more apt to also be able to feel comfortable buying it.
Okay, good. Here's a question for you, Dr. Palke. It's from Chris Rubish, and the question is it always dumortierite related to minerals that cause pink? Because normally we associate dumortierite with the color blue.
Yeah, and I think it's something unique about the dumortierite that happens to occur with the rose quartz. The chromophore is going to be different in this case. There's a different chromophore in the kind of blue dumortierite as well. But in rose quartz, yeah, there are some pink varieties of quartz that are maybe not caused by this inclusion. There's some phosphorus can also be a chromophore in quartz. But for generally the most typical type of rose quartz we think of is this dumortierite related mineral inclusion.
Okay. And there's a question from an anonymous person in the audience, which says, when we see rubies with a higher concentration of iron than a low iron content, quote, pigeon blood rubies, what effect does this have on the color and appearance of such rubies?
Yeah, so I sort of touched on this a little bit. When you have low iron, you get more fluorescence out of the stone. What happens is when you put iron in the structure, the iron tends to quench the fluorescence. So it tampers down that fluorescence quite a bit. And you can still get some fluorescence if you shine a UV torch on the stone, but it's not going to respond as intensely to natural daylight in terms of its fluorescence. So if you have too much iron in the structure, you won't get that glow from the stone that you would get with the pigeon blood ruby.
Well, and I have a sort of an add-on question to that, if you don't mind. This is from me. Do such stones tend to veer towards yellow in some cases, slightly, or orangey?
The iron's probably not. You might get a little bit of a slight orangey type tinge to it, but it's probably going to more turn the stone darker, I think, right, than really give it an orangey type tone. Yeah.
All right. Very good. Let's see. Here's another one from Gabrielle Matisse, and she's asking, can you talk a little bit about the difference between the Jedi spinel and the Burma/Myanmar spinel, and other Burma/Myanmar spinel?
Yeah. So the Jedi spinel is tends to be what they call Jedi spinel tends to be the lower iron stone. So it's maybe sort of equivalent to like the pigeon blood, where you have a little more fluorescence, you have less dark tones, In this case, it's a little more complicated than the ruby, because iron not only tampers down on the fluorescence, but the iron also introduces darker tones just by its absorption properties. And so those stones are often coming from this specific mine called Mancine in the Mogok region. Mm-hmm. Other Mogok spinels tend to be a little darker in tone. You have spinel coming from Namia as well, which is not in the Mogok Valley, but those stones can also be quite bright in their tones as well.
Yeah. Okay. So Rachel Tournier is asking this question. She's wondering what makes kunzite chromophores so sensitive to light. Bond strength in the crystal structure, she's asking, or is it a changing valence? She's always been curious about it.
Yeah, so the manganese 3 is just a much stronger chromophore than manganese 2. So it gets a little complicated. There's these things we call spin forbidden transitions. It technically a manganese 2+ atom. It has 5 d electrons. It has 5 d orbitals where the electronic transitions can occur, and they're all occupied by a single electron. Technically, manganese 2+ should not have any electrons allowed. It has spin forbidden electron transitions, and which is why it's a weak absorber, because those electronic transitions that absorb light are very hard to excite because they're forbidden by quantum mechanics. Whereas manganese 3, you take away one of those electrons, now you have a hole, and you can start to move electrons between orbitals. I hope that didn't get too technical, but
oh my goodness, I think only Rochelle could really understand your answer.
Okay.
That was amazing. So a whole bunch of people are wondering about stones that weren't covered, you know, and we knew this was going to happen because, you know, like red beryl, why was alexandrite not included? What about imperial topaz and some of the others? There was carnelian. So, you know, does any one of you want to give that a try? Just a quick answer as to why we weren't able to cover everything.
Time.
Yeah, time is the big one, right? Okay. Let's see here. I think we're kind of reaching, a lot of the other questions was, first of all, a lot of comments saying how wonderful this was and they loved your voice, Joanna, and really good stuff here. So I think this is an interesting presentation. I think we can probably wrap it up pretty soon, because this is really a melding of a much more ancient art and science. There's really the metaphysical aspects, the history and lore of gemstones, which is much more ancient than the science as we know it today. In fact, that was probably the science of its day. So I loved seeing these two things brought together. I thought it was really extraordinary, and kudos to you both.
Thank you.
Thanks, Robert.
So just to let everybody know that if we're going to stop with the questioning now, but if you have any other questions, you can find us on Instagram, Facebook, LinkedIn, and Twitter. Thank you so much, everybody, for coming and joining us again today, and then hopefully again next week. And next week we have a very interesting talk. It'll be, the speaker will be Yusuke Katsurada, and he will be presenting on Tangled Up in Neon Blue, a review of the Paraiba tourmaline. So that's going to be amazing. So again, thank you both. I really appreciate you being here and answering all of those questions. Some of them a bit thorny, but you are great, both of you. Thank you so much. Thanks, everybody.